So question letter B. The water surface is 0.9 above the top of the gate. So here, uh, the water is above 0.9 meters from the gate. And we solve that. We need to solve first the hydrostatic force, which is gamma bar H times the area. So our bar H here is 0.9 plus the half of our height, which is 1.5. So this is 0.9 and this one is 1.5. So our bar H here is 0.9 plus 1.5, and that is equal to 2.4 meters. So we can now have our hydrostatic force, which is F is equals to 9.81 times 2.4 times the area submerged, that is 3 times 1.5. And that's 9.81. Let's just use the calculator. Times 2.4 for bar H times the area, 3 times 1.5. That is 105.95. Our hydrostatic force is 105.95 kilonewton. Since we cannot use our shortcut for the location of our center of pressure, we need to look for the eccentricity, which is um, its formula is E is equals to inertia over area times T bar H or bar Y. So the inertia for our rectangular, that is IG is equals to BH cubed over 12. So our eccentricity here is the base is 1.5 and the height is 3 meters cubed over 12 over the area submerged, which is 3 times 1.5 times our bar H, which is 2.4 meters. So our eccentricity here is 1.5 times 3 cubed over 12 over 3 times 1.5 times 2.4. And that is 0.3125. Our eccentricity is 0.3125 meters. So our eccentricity here is, and this is the center of pressure, 0.3125 meters. Since we have now our location for um, center, since we have already now our eccentricity, we can now have our location of the force, hydrostatic force from the top or the hinge. and that is just 1.5 plus 0.3125. So since this is hinge again, this is 1.8125 meters. So we can do now our summation moment from the hinge. That summation moment from the hinge is equals to 0. Again, we can do our x and y component here, and our angle here again is 45. And for our horizontal, that's p cosine 45. And for our vertical, that is p sine 45. Again, we're using the angle in the red color. And since we already have our components, the force components, we can do our summation moment from the hinge. And we can transfer or move our horizontal force from here to here because of the principle of transmissibility. That's P cos 45. So now we can now solve our force. That is summation of hydrostatic force. That is 105.95 times the summation or the moment arm. That is 1.8125 meters is equal to P cos 45 times the moment arm, which is 3 meters. And we can solve it here with our calculator. That's 105.95 times 1.8125 meters and equals to x cosine 45 times 3. That's moment r. And we can have an answer of 90.53, or in our choices, that's 90.52. So here, our force to keep the gate closed is 90.52 kilonewton. And that is letter C.